Ever looked at the ingredients label on a pack of hot dogs and been really confused? If I can't pronounce half of what's in my hot dog, should I be eating it? A little chemistry can help answer that question. Hot dogs contain a lot of compounds, held together by ionic bonds. When ionic bonds form, there's a transfer of electrons from one element to another. Unlike ionic bonding, electrons are shared in covalent bonding. Valence electrons are a big deal. It's important to know how to determine the amount of valence electrons an atom contains. Let's just keep it simple and call them VEs. VEs are the outermost electrons in an electron cloud. They participate in bonding, and they determine the chemical properties of an element. The group numbers on the periodic table hold the answers. You like it when you're told the answers, right? All elements in the same group have the same number of VEs, and that's why all elements in the same group behave the same way. These elements have similar chemical properties. Look at this. You're not going to believe how easy this is. All elements in group 1 behave the same way and have one valence electron. All elements in group 2 have 2 valence electrons. Skip all those elements in the middle. We don't care about them for right now. Look at group 13, group 1, 3. There's also another label on the top of this column, 3A. See that? All elements in this group have 3 VEs. Seeing a pattern? Find carbon. It is in group 14, or group 1,4, as I like to think of it. It also has another label, 4A. How many VEs does carbon have? Yep, there's 4. Elements in group 1,5 have 5 VEs. What about oxygen? That's right, oxygen, along with sulfur and selenium, have 6 VEs. Elements in group 1,7 have 7 VEs, and elements like helium and neon in group 1,8 have 8 VEs. Look at all them pretty dots. These pictures are called Lewis dot structures. The VEs surround each element's symbol. All elements want 8 VEs. 8 VEs are needed to completely fill the outermost electron orbital. Elements are all wannabes. They all want to be just like the noble gases, which are unreactive, content, and have full orbitals. See, they all have 8 dots. Can't put any more in there. Some elements are closer to being superstars like noble gases than others. Check out all those elements in group 1,7. They have 7 VEs and are so close to that happy number 8. Those elements are all ultra-reactive and like to steal electrons. But what about group 1? Lithium, sodium, and potassium only have 1 VE and are a long way off from reaching their superstar status. But those elements are really reactive too. Just below that outermost orbital containing 1 tiny electron is a full orbital of 8. So what's an element to do? This is why ionic bonds form. Some atoms will lose electrons, while other atoms will gain electrons. Everyone is happy. But really, there are no losers in this ballgame. Everybody gets a trophy. When atoms lose or gain electrons, they become ions, or charged particles. There are 2 types of ions you need to know about, and their names are kind of weird. Metals become cations when they lose electrons. When negative charges go away, an atom becomes positively charged. Nonmetals form anions, or negatively charged ions, when they gain electrons. Remember, we are adding or taking away negative charges only. The number of protons, or positive charges, does not change. The ions' charges hold atoms together, creating a bond. So how do you remember all this cation and anion stuff? Well, it's kind of silly, but I like to think of cats. And cations are positive. Cations, positive. Oh, anionic compounds are electrically neutral. This means there are equal amounts of negative charges and positive charges. This information will come in handy when we're writing chemical formulas. Elements in groups 1, 2, and 13 will lose electrons, forming cations. Elements in group 14 can lose or gain electrons, and elements in group 15, 16, and 17 will gain electrons and become anions after bonding. Okay, so let's put some metals and nonmetals together. What do you call these new compounds? Well, there are 3 steps to naming them. Step 1 is to write the name of the cation. Step 2 is to write the root of the anion. And step 3 is to add "-ide" to the end of the root of the anion. Let's look at an example. Let's say sodium, a metal, wants to bond with chlorine, a nonmetal. It's easy as 1, 2, 3. Follow these steps to find out what it's called. First, write the name of the metal. Done. We've got sodium. Sodium is in group 1 and will be the cation because it will lose electrons and become positive. Step 2 says to write the root of the anion. Chlorine is in group 1,7 and will be the anion because it will gain electrons after bonding. To find out the root of the anion, you can usually just drop the last syllable. In our case, we have chlorine. "-ine" is the last syllable, so get rid of it. Step 3 says to add "-ide" to the end. So our new compound is called sodium chloride. Okay, so far so good. Let's do one more example. What will happen when magnesium and sulfur bond? Well, step 1 says to write the name of the cation, magnesium. Step 2 says to write the root of the anion, in our case, sulf. And step 3 says to add "-ide" to the end. So our new compound is magnesium sulfide. Wow, that is some heavy stuff. And you thought you'd be learning about hot dogs. Well, hot dogs contain a lot of complex ionic compounds that are put there to mainly preserve the flavor and the texture. So, should I be eating these compounds? Well, let's just say the next time I go to the ballpark, I'll probably be sticking to a burger. But that's just me. Till next time, guys. I'll see y'all later.